section, section 5.8, we're going to talk about geometric probability. So before we talk about why we're talking about probability at the end of chapter 5, let's do just a quick kind of recap of what we learned about probability already. So what we're talking about is theoretical probability. And that just means that we're using math, we're using what we know about whatever it is we're talking about, formulas, whatever, to figure out the way the probability should work. We did a little bit with experimental probability before. Experimental probability is where we actually flip coins and count how many heads and how many tails we get, and then calculate what actually happened. So we're not measuring, we're not doing an experiment, so we're talking about theoretical probability because we're using math, we're using what we know to figure out the probability. Did anybody remember how we said, just the very simplest way, that we calculated probability? Anybody remember? We had something that we said a lot about probability. Anybody remember? It was a fraction. We made a fraction of two things. Nobody? Probability we said was the favorable, and I'll write in shorthand first, over the total. And we said it in a little more technically, we said the favorable outcomes let me move that over a little bit. Over the total outcomes. But the way we usually thought about it was favorable over total. Figure out how many ways that are whatever it was could be favorable, and we divided by the total number of ways that whatever was happening could happen. We said that the probability was a number between 0 and 1. Or if we change it to percents, between 0% and 100%. We usually wrote our number as a fraction, but we could also write it as a decimal. And we said that if we had a probability of 0, what did that tell us about whatever it was we're looking at? What's a probability of 0 mean? No chance. It's impossible. Right. 0 equals impossible. Or no chance. And a probability of 1, and that was also 0%. 0%. And a probability of 1 or 100%. What did that mean about whatever it was we were talking about? Well, if we're saying 100%, probability of 1 or probability of 100%, what is that? Certain. It has to happen. So probability favorable over total. We get some number between 0 and 1 or 0 and 100% when we change it into a percent. 0 means it's impossible. There's no chance of it happening. And 1 or 100% means it has to happen. It's certain. There's no way it can't happen. So let's look at a quick example, just calculating theoretical probability like we did at the very beginning. So we have our bag with marbles. Probability problems lots of times have to do with bags of marbles. And we have 20 in there. 20 marbles. And we're going to say we have 5 red. We're going to have 5 blue. And we'll have 10 green. And we're just going to calculate 3 probabilities. We want to calculate the probability. We reach in, we pull out 1 marble, and we pick a red. So what's going to be our probability of picking a red marble? 5 out of 20. 5 is our favorable. And we have 20 total marbles. And we reduce it. So that comes to 1 and 4. How can we, what's 1/4 as a decimal? 0.25. And as a percent? 25%. So we have our probability is 5 out of 20. We usually reduce that to 1/4. Our probability would be 1/4 or 1 in 4 or 0.25 or 25%. All of those are the same way of saying the same probability. So what is going to be the probability of blue? Same thing, right? We have 5 blue, we have 20 marbles, so it's going to be the same. Probability of blue is 5 out of 20. 1/4, 0.25, or 25%. And finally, what's the probability of a green? 10 out of 20. Favorable is 10. Out of 20, 1/2 as a decimal, 0.5 as a percent, 50%. So all of those are the same, telling us the probability of picking out a green. Well, now we want to know why. So this is all nice, but we're talking about geometry now. At the very beginning of the year, we talked about probability, and a lot of you said, "Why are we talking about probability in geometry?" And I said part of the reason is the new standards tell us that we need to learn probability in geometry. But now it should, what we're going to do with probability now should tie in a little more with geometry. What we're going to look at now is, rather than bags and marbles, we're going to look at a situation like this one. So I have this target. Let me move that a little bit. It's better. So here's my target. And we're going to say the radius of the big circle is 5 units, and the radius of the small circle is 2 units. And we want the probability that we're throwing a dart at random and it's going to hit this target. So we want to figure out the probability that our dart hits this small circle. Well, our probability is still going to be the same thing, but what would we guess the probability has to do with now? What has something to do with the radius. So the radius of this one, the big circle, is bigger. The radius of this one is smaller, so it's going to have something to do with the radius. But what have we been studying for this whole chapter? The area has to do with the area. So we're going to say, in a situation like this, our probability our geometric probability, that's why we're studying probability in this chapter, is the favorable area divided by the total area. Same idea, favorable over total, but now we're talking about areas. And the area of the circle has to do with the radius, just like you said. So it does have to do with the radius, and the radius tells us something about the area of the circle. So this is how we're going to calculate geometric probability, favorable area over total area. So for this example, what is our favorable area? What are we trying to hit? We're trying to hit the little circle. So the favorable is, how do we find the area of that equals, I'm going to say, small circle. And how do we find the area of that small circle? Pi r squared. So we're going to say pi times the radius is 2 squared, which I'm going to leave pi in there. I'm going to write an exact answer. I'm going to write that as 4 pi units squared. And with probability, we usually don't worry about the units because they end up canceling out. But we'll write it in for now. What's the total area? What part of this is going to be the total area? The big circle. And we find the area the same way. Pi times 5 squared, and we get 25 pi units squared. So the probability is the favorable, 4 pi, divided by the total, 25 pi. And what happens to the pi's here? Anything divided by itself is 1, so these just cancel. We don't even have to worry about them. And our probability is 4 over 25. If I turn that into a decimal, it's about 0.16 or 16%. So if we throw a dart at random into this target, there's about a 16% chance that we would hit the small circle. And we figure that out by finding the favorable area, dividing by the total area. It would depend on how it told you. It might say give an exact answer. If it didn't say, and you wrote, and you plug this into if you plug this into your calculator, 4 times pi, and you divide it by 25 times pi, you'd still get 0.16. So if you put 0.16 or 16%, you'd still be good. If it asked you to round to the 10th, then I would need to keep one more decimal place. So any other questions on this example? We're just going to look at one more example, and then that's all we're saying about geometric probability, because it all just has to do with finding areas. All right. So here's our example this time. We have rectangles. Here's one rectangle. Here's my other rectangle. And we want the probability that our dart hits the small rectangle. And the dart's being thrown at random. So this one is, the dimensions here are 12 and 4, and we'll say this is 6 and 2. So how are we going to find this probability? What was it? Got to find the areas. So what's our favorable area for this one? The small rectangle, and the area of that small rectangle is what? 12. 6 times 2. I'm just going to write those in just so we have them there. And what's the total area? 12 times 4, the area of the big rectangle. So I get 12 over 48, which is reduced. One in 4, or about 25%. So we have about a 25% chance of a dart thrown at random hitting the small rectangle. Any questions on geometric probability? Yeah. No. If the problem didn't ask you specifically, 1/4, 25%, 0.25, they would all be fine for the answer. All right. So geometric probability just has to do with area. That's why we're talking about it at the end of our unit on area. Okay. That's all I had to say today.